Okay, so we've been talking about right angle triangles, and we talked about a few special ones. We talked about this 45-degree one here, 45 degrees. So right angled isosceles triangle, I guess, line symmetry. Right, now we're going to start going to talk about the trig ratios. I'm going to call that angle theta. This is a theta, which is a Greek symbol, which is a letter th, and equals theta. Now, why you call it theta, I don't really, that's right angle there. I don't really know why you call it theta, but you do. So we're just going to call it theta because everyone else calls it theta. Just a few preliminary comments. Again, I want you to observe I'm putting it in standard form. The right angle is down here, because that way I don't need to muck around with writing backwards ones or upside down ones or any rubbish like this. The right angle's always there. Okay, so there's my angle theta. What else do I know about this triangle? There he is. There's theta. That's my right angle. This angle in here, well, we know that the internal angles of a triangle, they add up to, I'm going to call it x for the moment. So the angles add up to 180 degrees. We know that from geometry. And that's 90 in there. So we know that 90 plus theta plus x, that's theta, that's x there, equals 180. So we can take this 90 over the other side, bonk, and because it's a plus there, it's a minus on the other side. Theta plus x equals 90 degrees. So x equals 90 minus theta. There we go. That's quite nice. So whatever theta is, x is 90 minus that. So if I make this triangle, I'm going to draw it a bit bigger. Here we go. Let's zoom in a bit. There we go. There's my right angle triangle. Theta, I'm going to say, equals 20 degrees. So this angle here is going to be equal to 90 minus theta, which is 90 minus 20, which is 70 degrees. So I can just write it in there. There you go. And I guess you could prove that in any number of different ways, but for the moment we'll just observe. So as this angle here gets bigger, this one gets smaller because it's 90 minus something that's getting bigger and bigger. Let's try making theta a bit bigger. Well, let's make it 45 degrees. There we go. Theta equals 45 degrees. It's not a perfect diagram, is it? But this one here is going to be 90 minus 45, which equals 45, I guess. So you can see that as this angle gets bigger, it's gone from 20 to 45, this one's got smaller. It's gone from 70 down to 45. And of course, if I make theta really, really small, I won't be able to draw it very well. That's supposed to be a triangle. Oh dear. Theta equals, let's say, 5 degrees. Well, this one here, if that's a right angle, is going to be 90 minus 5, which equals 85 degrees. And that looks about right, doesn't it? Okay, they're called complementary angles. Yeah, complementary angles. So complementary angles, angles, add to 90 degrees. You can see that if I say that theta and x are complementary angles, angles. Well, I can see that if I have a right angle here, that's supposed to be a right angle in there, and I just put any old line here at all, if that's theta and that's x, then theta and x are complementary angles because they add up to 90 degrees. So you can see what complementary angles look like just by sticking them here. So what we're trying to say is that when you've got your right angle triangle, which is here, this angle, call it x, and that angle there, call it y. They're complementary angles. Well, I can sort of create a ghost reflected, I'm not drawing it very well, we can sort of flip it over and draw another copy of it here. So now we've got a nice a rectangle now. We've got the original triangle and we've sort of created this other sort of ghost triangle above it here. So it's a nice rectangle. This is a rectangle we can see that that angle there is x because this angle here matches that angle there. We can see that that angle matches this one. It's like a big Z, isn't it? In geometry, you call it Z angles. So you can see that x and y just appear are complementary angles because they fit together to make a right angle. And of course, oh, that's a right angle, isn't it? But this one here is going to be y, isn't it? Because that angle and this angle are the same, so they're complementary down there as well. Okay, that's quite nice. I'm going to stop there.